Okay, so today I'm gonna make a tutorial for MiniNAM. And what is a MiniNAM? We can check it here. That is a MiniNAM, and we'll show you how you can download it and how to use it. But anyway, the first of all, you will see how it works. And basically, it'll be awesome. It will dynamically show you how the packet flow through the SDN networking. And we can see that. So now uh, let's go from H1 in the root, from H1 ping H3, and the counter is 3. So we're gonna send the 3 packets and see how it works. Okay, so anyway, you will see how the system works, and basically it will show you how you can download and how you can set up everything for doing the experiment. Okay, so now we're gonna quit the Mininet and start from zero. Close the terminal. Okay. Okay, so the first thing we need to do is we need to download the Mininet. Okay, so here's a web browser. You go to GitHub and go to this web, and basically you will see that's where the Mininet is. And they give you a brief tutorial and introduction of how the software working. So they add some new feature, they show you how to install, and they provide you the documentation, which is very powerful. So today I'm going to show you some very basic tool and very basic function of the MiniNAM. So the first of all, let's install. So how to install? Very simple. Just clone, just copy and just copy the link. And then after that, you just find whatever folder you prefer, and then open a terminal. Use the git clone and copy and paste the GitHub address, and then you're done. And you will have the folder like that. So basically, you're finished installing the MiniNAM. And right now, we're gonna check the very basic function of a MiniNAM. So there's a license, and also the README, and README is very useful too. So this is the MiniNAM. So in my computer, I will start the simplest topology by the MiniNAM. And how to start it? Simple. So let's do it. Let's clean the system for a new Mininet creation. Okay, after that, we're gonna sudo python mini9 py. Okay, so right now we start the mininon. So we can take a look. They already add the controller. Why? Because in my system, I have the POX, which is the default controller from they're in a package from the installation of a Mininet. So I use a default controller POX and to create a topology in the simplest way, which is sudo mn. And right now, the network supposed to work. So we will do a very simple command. Use a ping h1, ping h2. So basically, you will see how the packets go. Okay, so meanwhile, you can check the preferences, okay, and also the filters, TCP, UDP, and ICMP. So I didn't use a help because a help is just right there. You prefer to go to the GitHub and try to learn more by the documents. And also, this is a file we can load and save the preferences. And now we're gonna quit because that was so simple. Okay, so we're ready for the next experiment. Right now we can turn the Mininet, the MiniNAM, and we enter the directory of examples. We can see there's like two, three examples: routing, NAT, and load balancer. So today I want to show you two examples, which is a routing and NAT. So let's go to the MiniNAM. In this in this folder, there's like a several files. I want to introduce the different function of each file, the role of the file. So MiniNAM is a MiniNAM. That's all you know. So it will create the graphical user interface and the spanning tree. Let's open it. We can see that actually it is just a topology. It created a topology, we upload it, and that's it. And here it use a simple switch STP. STP is a spanning tree protocol, and this is a regular simple switch 13, which is the 1.3 OpenFlow the version. So that's all we needed. And besides, when we go to the RYU, go to RY, the directory of a app. So from here, we can also notice that there is also a simple switch STP. So we're gonna use this one. Basically, they're the same, but I want to use that one. So if you don't know what is a spanning tree protocol, and you have better read the document of RYU, so you will know more about it. And okay, so right now let's turn on our terminal. We're gonna start the controller right now. Okay, So the controller is running. Now we're gonna open the README. The README have a command, and we will need it. Copy. Open a terminal inside this folder. We're gonna copy and paste. Then we're gonna have the topology of a spanning tree. If you don't know spanning tree, and now you know. Okay, so from this topology, and we can notice from host 1 to host 2, and there are like two possible routes together to get each other. So the packet from H1 to H1 and then to H2 to H2. So they can go through this path with no problem. But also the H1 can go S1, S3, S2 and then go to H2. So there's like a two possible way. But the problem may happen. The packets may go since for the first time they don't know where to go, so they will use a flood. So after they're using their flood to S2, the S2 will go flooding and back to S3. So they would go to the different, so they will go into a circle and circle again. And after that, they will create the broadcast storm. So that is basically the spanning tree, and we need some solution to solve the problem. And the way we solve it is to create the protocol. And right now, since we already use the correct protocol, so we should try. And now we're gonna, right now we're gonna notice something that to implement this experiment, we're still short of something, which is a protocol. They didn't have any protocol yet, but remember, so at the beginning, we're using the version of 1.3, so we also need to set the version of OpenFlow for each switch as a 1.3. So that is the command we need to set to each switch. And how? And this is a way. So we need to figure it out. Where's the Mininet? Okay, so from the Mininet, let's go extern S1, S2, S3. Okay, so from the three switches, we're gonna set the version of the open switch. Copy and paste, and copy and paste. And so far, everything is done. So it's supposed to work. Right now, we're gonna try S1, H1 ping as H2. Let's take a look. Yep, it works. So after several failed packet forwarding, and the router finds out the way to forward the data. And now we're gonna do one more thing. Let's link down this one. So it will go to another route. Link down. Let's wait for a while. Yeah. So right now you will see after wait for like 30 seconds, you will see how the switch is learning and how it's going, how it's changing the route. Okay. So that is an experiment of a spanning tree. I'm gonna close it. Okay. And the third experiment, I'm gonna do the NAT. So let's go to Mininet. Let's go to NAT. So let's go to README. So this example will show how the packet is flowing through a router that uses NAT for hosts. So what is NAT? NAT basically it works for a networking when a packets go from a local to a global. So it'll change their address automatically. So in this way, we are going to start the topology. Since everything working is written in the already coded in the file of a good NAT. So what is a bad NAT, by the way? It just changed the protocol from here in from 1 to 0, and then this forwarding it doesn't work. So that is a bad NAT. And a good NAT is right there. So everything working is here, and we can use the existing protocol to create the NAT researching experiment. So I'm gonna do the copy and paste, and then in this folder, I'm gonna open the terminal. Why? Because for this experiment, we need to make sure the MiniNAM and the file good NAT, the topology and MiniNAM, they're both in the same folder. That's how you can start. Uh, that's how you can start the MiniNAM. That's very important. Yep, there it is. And now we have it. And what we need to do, go to the terminal. We try to ping what is the address of the H3 counter 3. Okay, then let's go to see it. So from here we can see From this animation, we see the address altered based on the switch and router, based on the router actually. Okay, so that's is the tutorial for the very basic fundamental and also for the two application which is NAT and the routing. The routing is a spanning tree experiment. So hope you like it and learn and use Mininet to do some experiment and it will enforce the power of a Mininet. Thank you.